So we're talking about algebra. It's basically a way of doing things, and to make life easier, it actually makes working things out easier. Okay, the idea of algebra is, and we're going to look at that more from next lesson, it's called generalized arithmetic, which is saying instead of doing something, making up a rule for each different set of numbers that we have, we can use symbols that represent a certain set of numbers to make a rule or a relationship that we know will work between these particular values. Again, and so basically it's number patterns. Algebra is a lot about patterns and being able to predict things. And so this paragraph is just saying patterns and rules are an important part of science and maths and many other things, economics, finance. Because if you have a pattern, it means you can work out how it operates, what happens with the pattern, and then it also means you can predict what will happen. Okay, and that's why we see that the universe, the way it's all put together, is actually extremely ordered. Okay, it's governed or it's ruled by all these set of strict rules and the way that things are done. It always seems to work the same way. Gravity always works the same way. So we can use algebra to represent, have an equation that shows the strength of gravity on Earth, depending on how high you press. Or how fast something goes and how much wind resistance there is based on, you have an equation using algebra that gives you a relationship, and you can just put different numbers in, depending on how fast you're going, how big your car is, how much surface area there is. All these things are taken into account, and it works out your speed or the wind resistance or whatever it might be. So it's actually something that really helps us to predict future events. The idea of patterns is very important. So today we're just looking at a very simple version of patterns and thinking about what the relationship is between the term that it is, the order of the pattern, the position it has, and how many things or what the value of that pattern is. So many patterns made from objects or symbols, and we can represent that in mathematics. Because of things in the physical world, the way you move, okay, the way you move your arm, the way that gravity acts on the body, or the way that you run or something, can all be explained in mathematical ways. Okay, some of them are simple models, others are very complicated. So we can have a look at this. So just look at this matchstick pattern. So what it's saying is, this is a pattern between the number of matchsticks and the number of squares. So when you have one square, you have 4 matches. That's obvious. Very simple pattern. When you have 2 squares, you don't have 2 separate squares anymore. You're sort of connected, so you have 7 matches. And when you have 3 squares, you have 10 matches. Yes?
We had 3 in this one.
Okay, in this case, yeah. Okay, so the first, and it's important to call this, we call this the first term. Okay, this is the first term of our pattern. Number 1. This is the second term. This is our third term. Okay, so the 5th term in this would have 5 squares, and it has 16 matches. So basically the idea of this is, instead of having to write, if you wanted to know how many matches would you need for 100 boxes, if we didn't have this idea of patterns and working out, predicting future events, predicting how it would be, we would have to actually draw out 100 squares and count the matches. But using algebra and patterns, we can say that you can work out what the pattern is mathematically and describe it, and so then you can say easily, well, when you have 100 matches, you have when you have 100 boxes, you have how many matchsticks. So it just so happens to be that when you have 100 boxes, you will need, does anyone know how many matches you might need? How many? Yeah. It's 301. Because the pattern here is, it's 3 times the number of boxes plus 1. Because you have 3, 3, and then you add 1. 3 matches, 3 matches, 3 matches, you always add 1. How many boxes there are? You have 3 matches for each box, and then always 1 at the end. Okay, so that's the way that we can describe this pattern in words. So we're going to do another example of a different sort of pattern where you just have numbers in a row. So if you have a look at this one. Okay, so I just said here, you've got for the number pattern 4, 8, 12, dot, 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 going along. So 4 is the first term, we can label it as 1. 8 is the second term, 12 is the third term. Write the next 3 terms. Frankie, what will be the next term after the... Yeah, so it's 4, 8, 12, 16. Lachlan, what's the next one? 20. Yeah, because it's going over 4. And then the next one is Nelson? 24. Good. I lined it before your day, so hopefully it's stable. Anyway, so that's the next 4 terms. And then we can just keep going, of course. You go up to 28, 32, dot, dot, dot. Okay, you can just go on forever. It's not, this pattern keeps building and building and building. So when we talk about describe the pattern, there's a few ways you can describe it. You can describe it as how do you go from one to the next. Okay, you can describe it like that. How do we move on from one to the next one? Or we can describe it also in terms of how do you link the number of the term with that value. Okay? So there's 2 ways. You can and the way we really want to describe it is saying, well, first term, if I know this is the first term, how do I know what the value is? Yeah, in this case it's times by 4, which means that if I ask you, I want to know what the 100th value is, how do I know what that is? Like 400, just multiplied by 4. So we're trying to find a rule that links number of the term with the value. Okay, so when I say a rule, that's what I mean. I'm trying to say, this is the first in line, that's 4. Second in line is 8. Third in line is 12. Fourth in line is 16. How do I link those numbers? In this case, it goes up by 4, but I can also say you multiply its position in the pattern by 4. Okay? Its position in the pattern is multiplied by 4. So then we can record this in a pattern as well, in a table, sorry. So I'm going to record this in a table. Right, so if I make a table here, so if I draw up a table, just roughly, if I draw up this table, I put a few values in. So what I mean by a table is, I say, well, let's call it N and V. So N is the order in the sequence, or the order in the pattern, which means the number of the terms. So 1, 2, 3, 4, 5. And then the V is the value. The V is the value of the term. So when it's the first term, it's 4. If it's the second term, it's 8, 12, 16, 20, etc. Right? Describe the number pattern for the nth term. For any number n, what's the number pattern? How do I get from n to v? Now, what do I have to do to n to get to v? Well, that doesn't work for 2 though. 2 plus 3 is 5. What do I have to do? Guy, what do you think? What do I have to do to n to get to v? 1 to 4, 2 to 8, 3 to 12. Times by 4. So what I can write for this value n is v equals 4n, which is 4 times n, or n times 4. Alright, that's our pattern described in a mathematical way. We're just seeing this in a table, and this essentially is representing the same thing. We've got a number pattern described with symbols in maths. We've got it on a table, seeing the relationship, and we can clearly see that it's v equals, this number is equal 4 times this number. You can have all sorts of patterns. And the longer you do algebra, the more it's going to get a bit more complicated, with different sort of patterns. Like you could square n to get this, or you could cube it, or you could add 2 and then take away 3, or divide it by 4 and then add 1. You can do all sorts of things. But the idea is you've got this pattern that you're working to. Okay, so if you could finish writing that example down, and exercise 201, I'll write it on the board, what I'd like you to do. Mrs. Mills is here to help us. So please take advantage of that.
I'll just stop the